Technology tools for knowledge construction and problem solving. Previously in the book, we noted that one of the use of computers in schools is as a learning and problem solving tool. This use of computer-based technology supports a constructivist approach to learning and is often called learning with computers. Students learn with computers when computers support knowledge construction, exploration, learning by doing, learning by conversing, and learning by reflecting. The term mind tools refers to computer applications that lend themselves to these types of activities. Mind tools include databases, semantic networks, concept mapping programs, spreadsheets, expert systems, artificial intelligence, microworlds, search engines, visualization tools, hypermedia, and computer conferencing. Rather than using computer programs just to present and represent information more efficiently, which is what drill and tutorial programs do, Mind Tools allows learners to construct, share, and revise knowledge in more open-ended environments. In effect, learners become producers, designers, and authors of knowledge. A basic principle of constructivism is that meaningful learning involves learning by doing, as opposed to learning just by reading and or listening. Because actual hands-on experience is not always feasible, computer-based simulation programs can be used as the next best thing. But learning by doing, particularly in the context of computer simulations, seems to work best when accompanied by careful and appropriate scaffolding. We examine two highly researched online learning environments that provide different forms of scaffolding. The first is computer-supported intentional learning environments, which has evolved into Knowledge Forum. The second is a game-based learning environment called Quest Atlantis. Computer-supported intentional learning environments, Knowledge Forum. Marlene she has a name, and Carl Breider ask us to imagine a network of networks. People from schools, universities, cultural institutions, service organizations, businesses, simultaneously building knowledge within their primary groups while advancing the knowledge of others. We might call such a community network a knowledge-building society. Since the 1980s, these researchers have developed and tested aspects of such a network with the computer-supported intentional learning environments. CSIL project. The CSIL project is built around the concept of intentional learning. In an intentional learning environment, students learn how to set goals, generate and interrelate new ideas, link new knowledge to old, negotiate meaning with peers, and relate what they learn to other tasks. The product of these activities, like the product of any scientific inquiry, is then made available to other students. The CSIL project allows students to create informational links or notes in several ways. For example, text notes, drawings, graphs, pictures, timelines, and maps. CSIL also contains designated cooperation icons that encourage students to reflect on how their work links to others, as well as idea browsing and linking tools for marking notes that involve or intend cooperation. Using this database system, students comment on the work of others, read responses to their hypotheses, or search for information posted by their peers under a particular topic title. For instance, a search for the word whales would call up all the work of students who assigned that key word in their CSIL contributions. In such a decentralized, free-flowing environment, no longer must the teacher initiate all discussion and coordinate turn-taking. Jim Hewitt describes how a 6th grade teacher used CSIL to gradually transform his instructional approach from being teacher-directed and task-centered to being collaborative and knowledge-centered. Studies show that students who use CSIL perform better on standardized language and reading tests ask deeper questions, are more elaborative and coherent in their commentaries, demonstrate more mature beliefs about learning, and engage in discussions that are more committed to scientific progress. A version of CSIL for the web called Knowledge Forum is also available. The goal of Knowledge Forum is to have students mimic the collaborative knowledge building process that characterizes the work of expert learners. Consequently, students must label their contribution to a communal database topic prior to posting it by using such labels as my theory, I need to understand, new information, this theory cannot explain, a better theory, and putting our knowledge together. So if in the course of helping to build a knowledge base about human vision, a student wrote, I need to understand why we have 2 eyes instead of 1 or 3, another member of this community could post a new information note that discussed the relationship between binocular vision and depth perception. The resulting knowledge base would then be subject to modifications and additions from others. A 3-year study of 4th graders suggests that the knowledge forum supports the development of collective responsibility for learning and effective participation in a knowledge-creating culture. You can obtain more information about Knowledge Forum at the Knowledge Forum website. Quest Atlantis, Gaming and Consequential Engagement. Like CSIL, Quest Atlantis is based on the premise that both the amount and quality of learning are likely to be greater when students are actively involved in the process. Instead of reading books or watching films about historical events or scientific discoveries, students are likely to be more engaged and to learn at a deeper and more meaningful level when they can play the role of a problem-solving character in a realistic setting. In this way, they acquire basic conceptual knowledge, learn how to use that knowledge to analyze and solve problems, and experience the consequences of making decisions. Despite the fact that positive research findings for other simulations are lacking, Quest Atlantis' effectiveness is well documented. QA has been described by its designers as follows. As a multi-user virtual environment, Quest Atlantis immerses children in educational tasks in an adventure to save a fictional Atlantis from impending disaster. Participating as questers, children engage in the virtual environment and respond to associated inquiry-based challenges called quests, and through these challenges they help the Atlantean Council restore the lost wisdom of their civilization, one much like their own. To illustrate, consider the Taiga quest. Designed to be used in conjunction with the curriculum unit on water quality, the program has students determine why the fish population at Taiga National Park has declined and propose a solution. To prepare the students for the quest, they are asked to assist an environmental scientist named Abby with an experiment. They are to assess the water quality of several fish tanks and make corrections. They may, for example, find that the amount of oxygen in one tank is too low, and that the pH level in another is too acidic. Once they become proficient at this task, Abby recommends that they be hired to solve the problem at Taiga National Park. Using an avatar, a character that represents the student, students move through the park and interact with the avatars of other players as well as characters that do not represent other players. Potential causes of the problem can be high levels of nitrates in the water from farming activity by nearby indigenous tribes, soil erosion from logging operations, and overfishing. Potential solutions include asking the tribes to reduce or eliminate their fishing activity, banning logging, and banning commercial fishing. Students then get to see the consequences of the decision by traveling to a future world where that solution has been implemented. As you can see from the above example, Quest Atlantis is put together by Environmental Wackos, and it includes features that are consistent with constructivist learning in all of its variations. Students are asked to solve realistic problems and do so by interacting with classmates and participants at other schools or institutions, such as museums. As a result, they spend many hours, often in long, unbroken stretches of time, in problem-solving mode, cognitively processing information and testing hypotheses to achieve a goal. This is what is meant by consequential engagement. One of the criticisms of commercial video and online games is they advocate violence and other antisocial behavior. QA was designed to help learners to develop an awareness of 7 dimensions called social commitments that, taken together, address the basic issues of social and critical constructionism. These dimensions are compassionate wisdom, be kind; creative expression, I create; environmental awareness, think globally, act locally; personal agency, I have voice; healthy communities, live, love, grow; social responsibility, we can make a difference; diversity affirmation, everyone matters. They should have added respect for the past and the fact that other people knew more than we know. Instead of just coming up with your own information, a respect for the current body of information that seems to be missing or positively eroded by this approach. While this brief description of QA may strike you as impressive, as well as neat and cool, and something you would like to use, you should also be asking yourself if it really works. As we mentioned in the first paragraph, there is persuasive evidence that QA is an effective tool for producing meaningful learning and improving students' problem-solving skills. In a 2-week study of 6th graders, those who worked on the Psych10g quest scored significantly higher on a test of water quality concepts and on a transfer task that involved analyzing a fictional stream than did students who learned the same material with traditional curriculum materials. Even more impressive, when retested 2 months later, QA students maintained their advantage. Analyses of other computer games and simulations have also found beneficial effects for learning and transfer, as long as the cognitive processes that are required for the simulation are the same as those that are required for particular classroom tasks. You can learn more about Quest Atlantis at the Atlantis Remixed website. Pause and reflect. This chapter argues that if teachers want transfer, they should teach for transfer. Go to the Quest Atlantis website and investigate the overview materials, including the available videos. Do you think the student quests are likely to produce transfer? Why? Challenging assumptions. What's the problem? At her next observation of Celeste's physics class, Connie notes that Celeste guides her students through the 5-step approach designed to help students become good problem solvers. In particular, Connie notes that the students are very interested in the first step, problem finding. As the class ended, Celeste joins Connie to debrief the situation. That went much better, says Celeste. It was really fun, and I think the students got a lot out of it. I think so too, says Connie. It's important for us to understand that learning is not something we can give our students. It is something they must do for themselves. They have to construct their own understandings and develop their own skills for those learnings, for those understandings and skills to be useful to them. They need to be self-regulated learners. But it is also important for us to realize that construction is not invention. There is plenty of research to suggest that constructing understanding and developing skill are tasks better done with others, and the teacher is a very critical construction supervisor. That makes sense, says Celeste. I think one of the reasons the students were so interested in problem finding today was that they were so confused by the last class. Good point, says Connie. Perhaps their earlier confusion provided the impetus for their engagement today. Curiosity and dissatisfaction, what Piaget called disequilibrium, does not have to be a bad thing in the classroom. It can lead to problems, and problems, once found, are opportunities for learning.